Hi, it's T. In this video, I'm going to go from start to finish how to run a machine learning model. I'm going to be going through what to do and why it's done. And essentially, this is going to be like a template for you going forward. So using this, you'll be able to, work on different machine learning models. And just to show that this is going to be different from other videos, I'm starting at what we're going to do. I'm going to explain it because like a lot of the training out there, like when I was learning how to work with these different models, they don't really explain it properly. So what we're doing with the machine learning model is we are trying to predict, we're trying to predict these three flowers. So we have versicolor, virginica, and setosa. These are three different flowers. And if I bring a flower to my model, I show my model a flower with a certain petal length, a certain petal width, and a certain sepal length and sepal width, it will accurately predict which flower it is based on this data. So that's what I'm trying to do with my machine learning model. And I will be training my machine learning model with um with a data set with that contains this information. So the machine learning model will be trained, it will be taught that when we have a flower with this petal length, with petal width and sepal length and sepal width combination, we get this flower. So that's how we train our model. But again, you want your model to be, well, not again, firstly, but again for me, because I have to keep, you as a data analyst working with learning models, you need to make sure your machine is generalizing and not memorizing, you know. So I'm going to go into more detail. So here we go. And the data set we're working with is the Iris data set. It's used a lot of data scientists and data analysts or anybody working trying to learn data manipulation. They're usually going to be familiar with, or they're going to come across this data set because it's a easy data set, well understood, clean data set, which is important so that you can use it for the purpose of teaching and you can get right into your machine learning model, because in some instances you're going to have messy data, which is real world data, with there's going to be gaps, there's going to be NAs, there's going to be section with NAs, and their things are not going to be in the right formats, and you're going to have to transform it to another format, and like that takes you away. Like that's very important, to learn how to do that, but that's a separate thing. That takes you away from what we're trying to do now. We're trying to just learn how to run a machine learning model. Machine learning model we'll be looking at today is KNN. We're gonna have to do some analysis. Anyways, you always have to analyze your data. That's standard, and you're gonna have to do some pre-processing before you use your machine learning model. So we load from, it's a library. It's inherent to Python. So from the sklearn library, we import Iris. So import load Iris. That's sklearn data sets, and we import load Iris data, and then we're gonna call the data. This is what our data is gonna be called. It's gonna be, so we're assigning load iris dot data, and we're calling it data instead of having to type this out the entire time. So that's basically all that's happened there. Um, and this is what the data looks like. So again, it's not in a nice, clean data frame format. And yeah, it's nice to see this as well because you can get data like this as well, real world data. But we understand this data set, that's why it's generally used. But what is happening here is we've got four columns: two, three, four, with different data. So you load the data, which is those four columns are these variables: the petal length, petal width. These are four, and sepal width. That's these four. You have to, the labels are separate. So then you go, this is the data shape, like I said. So we have 150 rows with four columns, the sepalent and etc. And then you need to load the target or the labels separately. So from the library dot target, and we're calling it labels. We could call it name, or we could call it species. We're calling it labels in this case, which is basically saying what. So we have we say this is one row. We have these different variables, sepal length, sepal width. I don't want to keep saying it every single time. And then we'll have the label, which is what is it? So the label is a versicolor, virginica, and so on, etc., etc. In this case, it's in 0, 1, and 2. A lot of machine learning models will require you to have the the label in this format, but in this case, we're going to change this shortly. But here we'll go into next, and I have loads of notes on this. Please don't let the notes deter you. The notes are important. You need to read them. If you're ever feeling stuck, read the notes and just check what's going on. I take a lot of notes and then just check what's happening. So in this case, we're importing another library, the NumPy library, and then we're going to use this to, because now we want to connect this data to this data to make our data set. You need to match what you get with the labels of the data set. And then we're going to reshape our labels data set that we loaded earlier. Remember, loaded labels from the library. Yeah. So we're gonna reshape this. And why are we reshaping it? That's probably a question you have. Or we're reshaping it because it's in one dimension. We need it in two dimensions. It's in a one-dimensional array. We need it in two dimensions, like this data, this array, so that it can concatenate. The only way we can join them together if they're in both in they both have the same dimensions. They won't connect otherwise. So that's the whole purpose of this code. Reshape, adding an additional dimension to that array. And then now that that's done, in this section, I'm just naming it data, the connection. So this is the data with the labels, and we're gonna call it data. And now what will happen is we're gonna have an extra column. This column contains all the labels, and this is it right here. Now we need to get into a clean data frame first, but just so you can see what's been done. So here we've imported we import pandas as PD, so it's just easier to work with rather than typing pandas the entire time. And here we know the organization of the columns. We understand the data set well. So in case you're asking, how do we know this sepal is the first column? We inherently understand the data set already, so we know sepal length is the first, sepal width is the second, that we're adding to something that is like that, but with the species section added as well. So just keep going back and forth just so there's full understanding. I want this to be as detailed as possible because I find if you miss a little bit of the details, if you miss some of the details, you get lost and then you just veer away, and you just keep digging yourself into a deeper hole of misunderstanding. So I feel like you need to get all of the little details to continue to build on your understanding. So yeah, so these are the names that we've initialized into this names. And then we have the data set. This is what we're going to call. So pd.dataframe, which is the data, and then we want the columns, and then we equals names with all these, and then we're going to make it a data frame. That's the pd.data frame. I'm going to make our data set with, which is this 150 rows, five columns. Now we're going to name it so it's nice and neat, and we're going to make it a data frame, and then we're going to look at the first five. So data set, we've called it data set. I'm going to go dataset.head 5. So we're going to look at the first 5 rows of data set, just see what it looks like. And this is what it looks like. This is our final product ready to work with. But we still have it like this, you know, which is, that's not as obvious. You want it obvious to someone looking at, like, what is the species? Species 0. Now, species 0, as we understand from this, species 0 corresponds to Setosa, and then species 1 corresponds to Versica, and species 2 corresponds to Virginica. And basically all we're doing here is we're getting our data set and we're looking at the species column and we're using the replace function to replace 0 with Setosa, 1 with Versicolor, 2 with Virginica. So then when we look at the first 5 rows of the data set again, this is what we see. Now this data set is very, what's the word for it? I'm gonna say it's continuous. So if the first 50 are Setosa, the next 50 are Versica, and the final 50 rows are Virginica. So if I was to look at the tail of this data set now, so if I said I didn't really, I probably should have added in because I just wanted quicker. I think it's quicker if I don't have to type in the code. So the that should be the final. The tail should be the 5 rows from the bottom of the data set. And here we see Virginica. So that's essentially it. The final 50, or if I put 50, you can see all 50, but I don't think it's necessary. I hope you get the gist from that. So I will pause it there.